You see that you have heard the proof that electron moving in a current carrying wire uh, create magnetism, and it can be proved with special theory of relativity. But what about permanent magnets and electron behaving like a tiny magnet? What about those cases? Can we prove that with theory of relativity as well? This video is about those things. Uh, well, we will be uh, trying to prove those thing how the permanent magnet works in terms of special theory of relativity without bringing a specific concept about magnetism and also electron behaving like a tiny magnet. Okay, first of all, let's jump into the electron part. Electron has two types of motion inside the atom. First, it rotates around the orbit, right? Uh, and also, it has spin. It's not an actual spin. We call it quantum spin, or electron has angular momentum in its axis, and this is another motion of electron. So two types of motion of electron, and we know that motion of charged particle creates this magnetism. First of all, rotation around the uh, rotation in the orbit and circulating the proton. Okay, so electron is moving from each reference frame. The proton is moving. Okay, so proton is moving. If you uh, electron is moving at a very high speed, right? Is very high speed. Okay, so since the electron is moving, it will see the proton is moving. Okay, since the proton is moving, there will change in its electric field. Normally the electric field is sphere, but it is moving now, right now. So electron proton is moving from electron's reference frame. Since its electric field, the proton's electric field is moving in a way, rotating the electron from electron perspective. The electric field of proton will shape different from the uniform electric field it spreads towards electron. We'll see that if the electron is sorry, the proton is moving, then its proton's electric field will be lot denser in one side, and in the opposite side it will less denser. You can have the same kind of result if you move it uh, s- if you uh, have a wheel and you rotate it and move it in a way, it will have the same effect. It And with those analogy in hand, we will say that the proton is moving from electrons reference frame. uh, Electrons reference frame, electric field is lot denser in one side and less denser in one side. they that will create the magnetic phenomenon. The denser side, we'll call it the north pole, and the less denser side, we call it south pole. uh, this is basically uh, this happens basically Lorentz contraction and time dilation altogether. uh, the electric field gets bended, and has it faces distortion. So when it feels, the electron feels more attraction uh, to the proton in one side, and less less attraction in other side. And we gave those thing uh, we call those things poles. And the since electron is uh, attracted to proton, we call we consider uniform electric field. Then the more attraction it is getting, we call that the magnetic force. In that case we add up, and on the other case we just instead of adding up we just minus the whole thing. So this is really this is the proof of electron being a magnet while rotating the proton using the concept of special relativity. What about the electron's own spin or its angular momentum? When electron moves, it's not actually spin. We call it quantum spin or intrinsic spin. When it moves in its list, for example, for simplicity, we call it it is moving in its own axis. We'll see that the electric field electron is generating. Okay, so electric field the electron is generating it. Gets denser in one side and less denser in one side. Okay, so this phenomenon creates actually the permanent magnet. But the rotation in the magnetic field created by rotation around the proton, it's much more stronger magnetic field, but uh, it usually cancels out when it is staying with a more and more larger atoms in a crystal or something, in a bond or in a being a part of that matter. Those thing cancels out, those magnetic moment cancels out. But those spin, the magnetic moment created by those electron spinning in its own axis, this actually creates the magnet, a permanent magnet. Okay, so we'll come to this. First let's understand the magnet, the magnetic moment created by own spin. Okay, so first of all, when the electron spin in own axis, the electric field is actually get more denser in one side and less denser in other side. We call the more denser side is north pole and the less denser side is south pole. Okay, so since you may ask, then how those poles we just produced out of nowhere, they don't actual no actual physical term, we interpret them to make the situation, to make the uh, our description easier. Okay, so when we see that, you may ask that, so the low density electric fields, electrons electric field side should uh, repel less each other. That means in general terms we will the word attraction. Okay, so that doesn't happen actually. So we got electron being magnet, having one side has having denser electric field, one side having less denser electric field. So when and we call it those electric field north pole and the south pole. Okay, so let's put south pole and south pole together. So you in general thing, uh, they should have less repulsion because of less denser electric field. But uh, in general case you will see that the north pole definitely should repel each other, and the south pole actually also repel each other. Only opposite pole attract each other. Okay, so why doesn't the south pole and south pole repel each other actually? So uh, in that case we see that, say for example, take example air. We know that air flows from a higher denser to lower denser area. Okay, so electron, one side has a higher density area and other side has a lower density area. When another electron is bring into this, and it also spinning like spinning. Okay, so uh, when those lower and lower density side, those lower density side cannot exist coexist together. Okay, why? Because the higher density side will try to get close to the density side to uh, since to have a balance there in terms of electric field density, because uh, it is not stable to have higher density in one side and lower density in the other side. They will try to, in order to be stable, they will try to have uh, average density all across. So this is the reason, and obviously North Pole and North Pole should repel each other because they have the higher density side. Okay, so even lower density side, the South Pole also repel each other because uh, this is not sustainable. Okay, so this is the explanation uh, of electron not being magnet by not by definition, by uh, the change of electric field due to the effects of special theory of relativity. In subatomic level, the relativity also stands out firmly. So yeah, this is what I was trying to say. So thanks for watching.